Well, hi there, boys and girls. Today we're going to find out how to go backwards, or how to undo a derivative. And then we're going to solve a differential equation. We've got a lot of things to do, so we're going to get right after it. And I'm only going to give you one formula. And that formula is the integral of u to the n power du is going to equal u to the n plus 1 divided by n plus 1 plus c. Now, I've used a word I've never used before, and it's called an integral. And this integral symbol right here means find the antiderivative. This means go backwards. So this is saying this was a derivative. We have to go backwards and figure out what the original function was. And this formula right here tells us how to do it. So let's just get after this. Integrate. This means to go backwards. Go backwards. So I need to think about that I took the derivative of some function, dy dx, was 6. And I've got to go backwards. So I'm going to show you how we get to this little symbol here. The first thing we do, if I think about 6 as my derivative, I'm going to take this dx and I'm going to multiply both sides by dx. I'm going to get that dy equals 6dx. And then we do this integral symbol, this little symbol right there. That's how you undo a derivative. The integral of dy is y, and now I've got y equals the integral of 6dx. So now I'm going to use this formula. Now I don't have a power of x, so I'm going to think about this as the integral of 6x to the 0. That would mean the same thing. So you could be creative with this. You could think, what could I take the derivative of to get 6? And that answer should be 6x, but we're going to use the formula. And that formula says if I have x to some power, I add 1 to that power, and I divide by that. So this answer is going to be 6x to the first over 1 plus c, which just simplifies to 6x plus c. And then we can check our work. Take the derivative of this and see if you get back to here. Is the derivative of 6x 6? Well, of course it is. Let's do another example. Integrate, this means go backwards, find the derivative of, the antiderivative of 3x squared plus 2x. So we're going to do our little formula. Our formula says add 1 to the exponent and divide by that. So this is going to be 3x to the third divided by 3. Now when you're integrating, just like with derivatives and you're going through a plus sign, you can just integrate one piece at a time. So now I've integrated 3x squared. Now I'm going to integrate 2x. And I'm going to pause because of the announcement. Hold on one second. Pausing. Okay, sorry about that. All right, now we're going to integrate the 2x as well. And you can think about this as 2x to the first. So this is going to be 2x squared over 2. You add 1 to this exponent and divide by that. That's how you go backwards. That should make sense because with differentiation, we were multiplying the exponent and subtracting 1. How do you undo that? Well, you add 1 to the exponent and you divide by that. That's how you undo it. And then you put this plus c here. We're going to figure out why we're putting that plus c, because I didn't address it in the last one. Okay, so now we're going to simplify this. This is going to be x cubed plus x squared plus c. Now let me talk to you about what c means. C is some constant. Whenever you take the derivative of this to check your answer, the derivative of x cubed is 3x squared. The derivative of x squared is 2x. And what's the derivative of c? What if I'd had a number here like 10? Well, the derivative of that would be 0, and so there's no way for me to know what that number was if there was a number at the end. So we're going to think about this as a placeholder. You know, maybe there was a number there. So in other words, whenever you go backwards from taking a derivative, there's some things you can't figure out unless you know a point on the curve. We're going to get to that later, but there's some things you just couldn't have known. So you can't exactly undo a derivative unless you know other information. Derivatives and integration, that's this squiggly thing, are basically inverse functions, but we'll talk about that much later. For now, I just want you to know how to go backwards. So let's check our work, and we did, and so this answer is x cubed plus x squared plus c is right there at E. Okay, let's take a look at another one. What about a product? Now, there's no product rule for integrals. So what you need to do here is you need to distribute through. We want to distribute this and see what happens. So this is the integral of x to the negative 2. I'm going to think about this 1 over x is x to the negative 1, so that would be x to the negative 3. dx. Okay, so I've distributed, and now I can do my little rule. I'm going to add 1 to the exponent and divide by that. So let's see what happens here. Negative 2 plus 1 is negative 1, and then we divide by that. So I've done the antiderivative of x to the negative 2. And then the next one is going to be add 1 to negative 3, you get to negative 2, and then divide by that. And then we're going to put a plus c here. Now, we notice that there are some negative exponents, but they don't match what we have, so let's simplify what we have. X to the negative 1 can drop down to the bottom, so that's negative 1 over x. I just brought this negative right here up, and I dropped my x down. I'm going to do the same thing here. I'm going to have minus 2 over x squared, and then plus c. And that is my answer. That was the function that we can take the derivative of and get to this. All right, what if I have a quotient? Well, there's no quotient rule for integrals either, but you should know that if you have a monomial in the bottom that you can separate this. So we can separate this into the integral of x cubed over x plus x over x dx, and then we can simplify. X cubed divided by x is just x squared, and of course x divided by x is just 1. So now I have something I can integrate or go backwards. I can find the antiderivative. Add 1 to the 2 and divide by that. You get x cubed over 3. Now what about this 1? If you have a number, just 1, you could think about that as 1x to the 0 if you want. Or you could just think, what can I take the derivative of to get 1 as the answer? And that is obviously x. And then you also have to put your plus c, because there could have been a number out here, we just don't know. So that answer was C. All right, last example, and that's actually solving a differential equation where we do know some information about the original curve. So what I'm going to do first is I'm going to multiply both sides by dx. You must show me this step. This is called separate variables. All right, and then, did I spell that right? Is it separate or is it separate? I'm going to go with this, but I'll look it up after this video. Hold on just one second. Okay, hold on right here. Gonna have to pause for another second because I gotta. Okay, well I just went and looked it up, and it is separate. So we're gonna fix that. This is me being silly. That's how you spell separate. All right, so you're going to separate variables. The next thing we're going to do is integrate both sides. And the way we do that is we put a little integral symbol here. We are integrating both sides. So integrate both sides. Now, the integral of dy is y. What did you take the derivative of to get dy? Well, y. Now over here, I'm going to add 1 to the exponent and divide by that. But this 1/3 can just sit there, just like with derivatives. When we're doing derivatives, we can just let that. Okay, that was like the 3rd time I had to stop that. Sorry about that, guys. So we're back here, and I think I was at integrating this. Anyway, oh yeah, the 1/3. The 1/3 can just sit there, just like with derivatives. We can perform our integration and then multiply by that constant. So I'm going to let the 1/3 sit there. Now I'm going to perform integration here. Add 1 to the negative 2/3. And you get x to the positive 1/3, and then divide by 1/3. Now dividing by 1/3 is the same thing as multiplying times 3, and those cancel, and I get y equals x to the 1/3 plus c. Now I am not done because now I actually have a point on the curve. I can figure out my plus c now. I have a point -8, 0. So what I'm going to do is extend this page, and I'm going to plug in the 0 for y, the -8 for my x, and I can solve this for c. And this is called handle your initial condition. Initial condition is the point on the curve. Handle the initial condition. So the cube root of -8 is -2. Add 2 to both sides, and I actually now know what that c was. That c was a 2. And I can come back up here, and it's x to the 1/3 plus 2, and it's right here. So that's how we can figure that part out. So anyway, I will see you guys tomorrow.